in problem 1, it asks us to take the limit as x goes to 0 of 1 minus e to the x over x. So the first thing you always want to try to do is kind of eyeball it and try to plug 0 in. So 1, right, minus e to the 0 is, e to the 0 is 1. So you're going to get 0 in the numerator, and then you're also going to get 0 in the denominator. So this indeterminate form is 0 over 0. So once again, we don't ever set the limits equal to 0 over 0, but it's good off to the side to right. I have an indeterminate form, because if you want to apply L'Hopital, you have to justify why you're allowed to apply it. So L'Hopital's rule says, well, I don't know, the numerator's approaching 0, the denominator's approaching 0, but if I take each of those derivatives, I can see which one's sort of getting there first. So now it's still the limit as x goes to 0 of the derivative of the numerator, so that's just negative e to the x, over the derivative of the denominator, which is 1. Now we try to plug in 0 again. So if I try to plug in 0, I get negative e to the 0 over 1, which is just itself, so I get negative 1, and that is the result of the limit. For problem 2, we have the limit as x goes to infinity of natural log of x over x. Well, the limit of natural log of x is going to go to infinity, and clearly x is going to go to infinity. So now L'Hopital's will apply. So I'm going to say, well, this is going to equal the limit as x goes to infinity of the derivative of the numerator, which is 1 over x, over the derivative of the denominator. So now this is just the limit as x goes to infinity of 1 over x. And that goes to 0. So the denominator, right, is getting bigger. The numerator is a constant. And so we said 1 over infinity is going to be 0.